This is Module 4, lessons like 2 through 8, 9, something like that. But this is numbers 1 through 17 on your review. So number 1 says, did male and female voters respond similarly to the survey questions about building a new high school? Recall the original summary of data. And there is your data. Did they answer similarly? Just males and females. So if you look at this, you would add up all the male and all the female answers. Well, let's just do that in number 2, which says complete the following two-way frequency table, and that way we can answer number 1 more clearly, because we'll have a total of our males and females. Okay, so the female yes votes were 154. The male no votes were 116. The female no votes was 114. The no answers for the female was 6. And that would give us a total of 241 here, 274 here. And if you add these up, you would get 273. Now, so for males, there was 119 to females, 154 yes votes. So we would say that females voted yes more than males for number 1. Okay. There was more of them that voted. So the percentages were probably about the same. Okay. If we said 119 divided by 241 and 154 divided by 274, okay, 119 divided by 241 is 49%. 154 divided by 274 is going to be a little bit higher at 56%. So there's only about a 7% more yes votes, which is not a lot depending on who you're asking, I guess. Okay. So there's number 1 and number 2. All right, number 2 says, page 2, number 3 says, use the above two-way frequency table to answer the following questions. If a randomly selected voter is female, what is the probability she will vote to build a new high school? So that was the 154 out of 274, and we just did that. So 154 out of 274 was equal to about 56 hundredths. So if a randomly selected eligible voter is male, what is the probability that he will vote to build a new high school? And that was the 119 divided by 241, and that was equal to about 49 hundredths. And you can see that here. Male total, female over the total. Now, number 4 says an automobile company has 2 factories assembling its luxury cars. The company is interested in whether consumer rates car product produced at one factory, more likely than cars produced at the other factory. So they're looking at the consumer rates. Factory A assembles 60% of the cars. A recent survey indicates that 70% of the cars made by this company were highly rated. So at both factories combined. This same survey indicated that 10% of all the cars made by the company were both made at factory B and were not highly rated. So here we're going to have to figure out a a frequency table of 1,000. So we can go ahead and plug in 1,000 right here. We know that this is going to be a total category. This is a total category. So what are our two categories? Well, we've got factory A and factory B. And then we have highly rated and therefore not highly rated. Okay? Now, it says that 60% are assembled at factory A. So that would be the whole total of factory A is 60%, which would be 600. Okay? We got that information right here. Now, a recent survey indicated that 70% of the cars made by this company, which means at both factories, was highly rated. So 70% are highly rated. So that's going to go down here as 700. Okay. Now we can go ahead and fill this in. This is going to be 300 and this is going to be 400. Now we got to know what percentages are highly rated and not highly rated. So if we keep reading, it says this same survey indicates that 10% of all the cars made at this company were both made at factory B and not highly rated, which means that would go right here. Both at factory B and not highly rated. Now we can fill in the rest because 300 plus 100 is equal to 400. Okay, well, 200 plus 100 is equal to 300, which means this has to be 400. And that's how you fill out a two-way frequency table, two-way hypothetical 1,000 table. Page 3 says a state nonprofit organization wanted to encourage its members to consider the state of New York as a vacation destination. They are investigating whether their online ad campaign influenced its members to plan a vacation in New York within the next year. The organization surveyed its members and found that 75% of them had seen the online ad. 40% of the members indicated that they are planning on vacationing in New York within the next year, and 15% of its members did not see the ad and do not plan to vacation in New York next year. All right, so complete the hypothetical 1,000. Now, we've got some categories that are not filled in, so let's go ahead and fill in those categories. If this is do not plan to vacation, this is plan to vacation. If this is watch the ad, this is didn't watch. Okay, so now our categories are filled out. Now let's go back and read and see what's going on. It says that 75% of them seen the online ad. So right here is going to be 75% of the 1,000, which is going to be 750. Now, 40% of the members indicated that they are planning to vacation in New York within the next year. So that's 40% of the entire population. So that's down here. That would be 40% of 1,000 planned a vacation. Now we can go ahead and fill these in. And let's see what else that gives us. 15% of the members did not see the ad and do not plan a vacation. So that goes right here. That's 15%. So what is 15% of 1,000? Well, that's going to be 150. And so we can now figure out the rest of the values. Okay. Now, it says, based on the two-way table, describe two conditional probabilities you could calculate to help decide if members who saw the online ad are more likely to plan a vacation in New York City within the next year. Okay. Well, how would we determine this? Well, we would say they watched the ad Okay? Those that watch the ad, plus what's another form that we could look at? Those that watch the ad and what else? How would we figure out this answer here? We want to come up with two conditional probabilities that we can calculate to decide if members who saw the online are more likely to vacation to New York within the next year, and then those who did not. Okay, so what we should be looking at then is, I guess, the members who watched the ad. So let's say those that watched and plan to vacation. And then the other one would simply be those who did not watch and still plan to vacation. That's going to tell us whether or not the campaign helped. So, are the events a randomly selected person watched the online ad, which would be this one, and a randomly selected person plans to vacation in New York City independent? Okay, so no, that is not. So we're looking at that. Okay, justify your answer. So let's look at the ones that watch the ad, okay, that plan to attend. Well, that's going to be 300 out of 750. And that's going to equal 0.4, so about 40%. Now let's look at the ones who didn't watch, which is 100, that still plan to attend, which is here. So that's out of 250. And that's also 40%. So those are independent events because they have the same probability. Okay, page 4. A survey conducted at a local high school indicates that 30%. Oh, let's go back to this one. That's how we know if it's independent or not, is if they have the exact same probability, and these two do. That's what it means to be independent. I know it kind of makes, we talked about this, that's kind of doesn't make sense that since they have the same probability, they are independent, but that is true. All right, page 8, or page 4, number 8. A survey conducted at a local high school indicated that 30% of students have a job during the school year. If having a job and being in 11th grade are not independent, what do you know about the probability that a randomly selected student who is in 11th grade would have a job? Well, if they're not independent, that means they do not have the same probability. So we would say that know about the probability that range does not, or that they have a job. We would say it would, oh, I cannot spell. It would, I try to spell them the same way. It would not be 30%. Okay. It can't be because it was 30% of the students having a job. So if it was independent, then it would have the same probability, but here it doesn't. So being in 11th grade would change the probability that they have a job as opposed to the local high school, the entire high school. So if you were in 11th grade, you're not going to be 30%. It's going to change the probability. All right. Number 9 says, at a high school, some students take Spanish and some do not. Also, some students take an arts subject and some do not. Let S be the set of students take Spanish, A is the number. Okay, arts. All right, Venn diagram. All right, let's do this. So students who take Spanish and an art subject. So this is both. We're going to fill in right here. That is both. Students who take Spanish or an art would be here. And here, because this is the art. Now, students who take Spanish but do not take an art, that would just be this side of the circle, this circle. Now, what about students who do not take an art subject? So those that do not take an art would be these that take Spanish and anything else. We don't care as long as it's not an art. Okay. Page 5. When a player is selected at random from a high school boys baseball team, the probability that he is a pitcher is 35 hundredths. The probability that he is right-handed is 79 hundredths. And the probability that he is a right-handed pitcher is 26 hundredths. Let P represent he's a player, R represent that he is a right-handed in the Venn diagram. Okay. So we have to fill this out. And we know that he is right-handed and a pitcher is 26. So this is going to be 26.26. Now we're going to have to take 35 and subtract the 26, and that's going to give us 0.9. And then we're going to do the same thing for that he's right-handed, and that's going to give us 53. And that should fill in that Venn diagram for you completely. Okay. Now, well, let's see. Is there anything? So 53 plus 26 plus 9. What does that give us? So that would be 89. I mean 88, sorry. 88. So then there would still be about a 0.12 over here that's not pitchers or right-handed. Okay. 11 says, of the light bulbs available at the store, we've seen this one several times. 42% are fluorescent, 23 are labeled as lifelong, and 12 are fluorescent and lifelong. Now, A says a light bulb will be selected at random from the light bulbs at this store, rounding your answer to the nearest thousandths when necessary. Find the probability that the selected light bulb is not fluorescent. Well, if it's not, that's the complement of fluorescent. So we would say 1 minus 0.42. And that would be, what's that, 0.58. Okay. The selected light bulb is fluorescent given that it's lifelong. So that's going to be F given L. Okay. Now, how do we find F given L? Well, that is just F and L divided by L. So we would say it gives us that they're fluorescent and lifelong is 12. So we would do 0.12 over what is L. L is 23. And that would give us about 0.52, 0.52, so about 52 hundredths. Okay. Now, are the events fluorescent and lifelong independent? So does that mean that they have the same probability? And no, they do not. Those are not the same. Because F given L is 0.52. And lifelong, those are not going to be equal. 0.52. Oh, wait, that is 0.52. So we'd have 0.52, and the probability of being fluorescent is 42, and that is not equal to each other. So no. All right. Page 6, number 12 says, when a person is selected at random by a very large population, the probability that this selected person is right-handed is 82 hundredths. If 3 people are selected at random, what is the probability that they are right-handed? Well, that's simply going to be 0.82 times 0.82 times 0.82. That's going to be equal to 0.55. Okay, so now what's the probability that none of them are right-handed? Well, that's not going to be very high. That's going to be 0.18 times 0.18, because that's just the complement of them being right-handed, right? And that would be 0.5%. So that's like 0.05. Now let's see, that may not be that right. 0.18 times 0.18 times 0.18. Yeah, I gotta go one more. That's what I was thinking. 0.05. Okay. When a call is received, number 13, when a call is received at an airline call center, the probability that it comes from abroad is 0.32, and the probability that is to make a change to an existing reservation is 0.38. Suppose that you are told that the probability that a call is both abroad and to change is 0.15. Calculate the probability that a randomly selected call is either from abroad or is to make a change from the existing reservation. So if you think about this in terms of a Venn diagram, it's told you that the center part is 15. So all we would have to do is subtract those and call this abroad, and this is to change. So what is 32 minus 15? That would be 17. And then 38 minus 15 would be 0.18. So there's to be just abroad would be a 17% chance, and to change it would be just 18%. Now B says to, oh wait, did we answer A? Calculate the probability that the random selected is either from abroad or, okay, so what we have to do here for A, we would say 0.32 plus 0.38, and then we would subtract the 0.15, and that would give us 0.55. Okay. Now, to do the B, it says, suppose now that you're not given the information in Part A, but you're told that the event call, and they are independent. So what that means, if they're independent, then what we can do is multiply 0.32 times 0.38, and that's going to give us 0.12. So then what we would do, what is the probability that selected call is either from abroad? So we're doing the same thing, except for with 0.5 instead of 0.15. So we say 0.32 plus 0.38 minus 0.12, and that would be 0.57 or 8, however you wanted to round that. Okay. Now, you should know these probability rules. I'm kind of breezing through this, but if you don't know them, you need to go back and look at your probability rules. 14 says a golfer plays 2 holes of a course. Suppose that on each hole the player will score 3, 4, 5, 6, or 7. With these 5 scores are equally likely. Find the probability that explain how the answer is determined. The player's total score of the 2 holes will be 14. Well, the only way that they can get a 14 is to score a 7 and a 7. And since they're equally likely, that'd be a 1/5 times 1/5. Well, what's 1/5 times 1/5 is going to be 0.04, because that's 20% times 20%. So 0.14 is A. Now B says that the player will score a 12. Well, now, they could score 12 by doing a 5 plus a 7, or they could do a 6 plus a 6. Okay, so what we're going to do is we're going to multiply these probabilities but add it to this probability. Okay, and we know that they're all the same. Okay, so that's going to be 1/5 over 1/5 and 1/5 over 1/5, and we already know that to be 0.04. So if we were to add that together or multiply it by 2, the answer would be, so this is A, this is B, this would be 0.08. '15 says a local utility company wanted to gather data on the age of air conditioners that people have in their homes. The company took random samples of 200 residents of a large city and asked if the resident had an air conditioner, and if they did, how old it was. Below is the distribution and the reports of ages of the air conditioners. Now, would you describe this distribution of ages conditioners approximately symmetric or skewed? Well, I'm going to say that's symmetric. Okay, we're going to call that, I'm just going to circle it. That is symmetric. Okay. Now, is the mean or the age distribution closer to 15, 20, or 25 years? Well, it's going to be closer to 20, right? It's going to be falling right in here somewhere. Now, is the standard deviation of the age closer to 3, 6, or 9? Well, now you're looking at the typical value away from the mean. So if we said it was 20, then 17 and 23 would be a typical distance away. And that looks right. We're not going to do 6, because that gets us all the way over to here. And that would get us all the way down to here. And it's definitely not going to be 9. So yeah, 3 would be your best bet. Page 8, number 16 says, the histogram below shows the distribution of heights to the nearest inch of 1,000 young women. What is the probability, or what does the width of each bar represent? What does the height of each bar represent? Well, the width is going to be what? The width of each bar is 1 inch. So this is going to be about 1 inch of height. Well, I can't spell height. Of height. Okay. The height of each bar is going to represent the proportion or the probability of the 1,000 women. Okay. And we get that as a proportion here. Okay. The mean of the distribution of women is 64.6 inches, and the standard deviation is 2.75 inches. Interpret the mean and the standard deviation in the context. Okay. So what we would say is about 68% of the population falls within this interval. And the interval is just simply 64.6 minus 2.75 and 64.6 plus 2.75. And that is 61.85, and this would be 67.35. So they fall between this range. 68% does. Now, C says mark the mean on the graph. Well, that's 64.6. And what else does it say? Mark one standard deviation. That's only 2.7, so we go to 61 point. It's going to be something like this. And 67 is going to be something like this. Okay. So we've done one standard. Approximate what proportion of the values are within. Well, we always say that 68% is within that. And if we measure that, that's 1 or 10, 10, 13, 15, 14, we can just come straight across here and add these up. But we would guess that to be about 68%. Okay. Now, draw a smooth curve that comes reasonably close to passing at the midpoint to the top of the bars and describe the shape. Okay. We would say that that is a normal distribution, mound-shaped, symmetrical. Now, shade the area that represents the portion that is one standard deviation from the mean. Well, that's going to be all of these values. Okay. 17, the weight of a car passing over a bridge have a mean of 3,550 pounds and a standard deviation of 870. Assume that the weight of the car passing over the bridge are normally distributed. Determine the probability of each instance and explain how you found the answer. Okay. Well, this means we're going to take the value, remember, value minus the mean over standard deviation. Okay, so for A, we would say 4,000 minus 3,550 divided by, 850, and that's going to equal 0.517. B, now that's going to be correct because that's going to give us the 0.517 because that's going to be 450 divided by 870, and then it's 517. Okay. Now B is going to be 3,000 pounds. Right here it is, minus 3,550 divided by 870. So that's 550 negative divided by 870. Okay. So that's a negative 0.63. Now, and 3, 2. All right. Now let's look at this next one here. It says that the car is between 28 and 450. So what we would have to do, we just do both of those. We'll say 2,800 minus 3,550 divided by 870. That's going to be about a negative 0.862. And then we would do 4500 minus 3550 divided by 870. And that's going to be about 1.09. Because that's going to be 950 divided by 870. Yeah, 1.092. I guess we could call it 92. Okay.